Hello, today's video lesson is going to be on Lewis structures. In the last couple videos we were talking about chemical bonding. What Lewis structures are going to do is going to help us to make sense of the valence electrons and how they're arranged in the molecule or in an atom, but more specifically in the molecule. Okay, so the idea is that we're looking at molecules that we know exist, and what we want to know is how are the electrons arranged. Remember, it's the valence electrons that are really going to cause all this chemical reacting to happen. So what Lewis was doing was he was looking at how these electrons, and he's the one that came up with this idea of valence electrons. And he's trying to find a way to make some sense out of it. Now, this is before quantum mechanics, which is kind of amazing that he was able to come up with this idea, and how it kind of correlates with quantum mechanics. Pretty startling, but anyway, so G.N. Lewis basically comes up with this idea in 1902. It was really is a way to explain it to his students. He was having trouble trying to get his students to see, working with this idea of electrons and stuff. So he found it was just easier to talk about them with dots surrounding elements. So one last thing to keep in mind before we start getting into this is that Lewis structures predict the bond structure, not the shape. Okay, that's going to come in the second part. So what I mean by that is if we look at water, okay, we draw the Lewis structure for water. Most of you know to draw water looking like this with two valence electrons in pairs on either side and then two bonds for the hydrogen. Okay, and that's fine, and that's what the Lewis structure is doing. It's showing us that there's 8 electrons around the oxygen. 2 of them are bonding electrons, and the others 4 that are there are the non-bonding pairs, and that's going to have a lot of impact on the shape. But if I were to draw the Lewis structure like this, there's really nothing wrong with that, okay? Except for a couple things. I'd be careful with making that little bump stick out. Kind of looks like an electron. Make your electrons nice and dark. But the shape isn't important when you're drawing Lewis structures. The interpretation of the shape is going to come later, okay? So let's look at some stuff regarding molecules and atoms. So atoms are pretty simple. All you're going to do is determine number of valence electrons based on the periodic table. You're going to write the chemical symbol, and then you just put the electrons. 1. Now, you don't have to really follow this rule with on either side, but, if you draw hydrogen like this, that's fine too. If you draw hydrogen like this, it doesn't really matter, okay, as long as you have 1 valence electron around that hydrogen. So we get to nitrogen. What's important is that we have to follow Hund's rule, and we're going to put 1 electron, make it nice and dark, 2, 3, 4, 5, actually 1, 2, 3, 4, 5. So that should be 5 valence electrons going around the nitrogen. Oxygen has 6 valence electrons, so 1, 2, 3, 4, 5, 6, okay? And that's your atoms. All right, they're pretty simple, pretty straightforward. You're not really going to draw atom Lewis structures, to be honest. It's not that hard. But what we're going to look at is Lewis structures for molecules, and that's really crucial. You really need to be able to do this. Okay, so things to remember when you're drawing the Lewis structures. There's 3 things that you want to do. Make sure that you include all the valence electrons for the molecule that you're dealing with. Okay, if you're missing an electron somewhere in the molecule, like if we go back to that one for water, where you have the electrons here, and you do something like this, well, according to this molecule, you should have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. 1, 2, 3, 4, 5, 6, 7. That's going to lose a point right there because you're missing, and there's you don't have all your electrons. So that's number 1. All atoms must be connected by at least a bond. That's pretty simple. I mean, you shouldn't have another hydrogen just sitting over here not bonded in there. Okay. 3, all the electrons are arranged so everything is somewhat stable, because we're going to see there's exceptions to the stability rule, but this also tells me that oxygen is not stable because its outer shell is not filled. It needs that other electron here to make it more complete. Okay, so that's pretty much it. If you have these 3 things finished by the end of your Lewis structure, you're going to be in pretty good shape. Okay, there are some exceptions to number 3 that we'll look at in the next video, but for the most part, you'll be just fine. Okay, all right, now I'm going to give you a handout in class that's going to go over the rules. I'm not going to put them on here, and I'm not going to write all the rules out. I'm just going to kind of go through how I draw Lewis structures. And there's 2 basic ways that I do this. Okay? Well, actually 3 ways I do this. One is let's say I take number 1. One way to do this is to just draw the Lewis structure for your individual atoms. Now, bromine has 7 valence electrons. Okay? And oxygen, I think that should be OBr2, by the way. It's a mistake. Forgot the 2. All right, and what I would do is I would draw the structure for oxygen. I would have a valence electron here, here, here. Okay, so this is one way to do this. And if I draw my other bromine, I would have the same structure. Okay, so oops, that's not a dot. So go back and erase. If this doesn't look like a dot, go back and fix it. One big complaint is that Lewis structures are too sloppy from the grade. Make yours nice and crystal clear. Even this little thing right here, I would maybe go back and flesh that out a little bit, make it look more like a dot than a line. Okay, make them nice and bold and big. None of this little, drawn bromine like this where you kind of do stuff like, these little faint dots everywhere. That's sloppy. Don't do that kind of stuff. I don't want to see that. Nice, even dots. 2 on either side, paired up. And that's the thing about Lewis structures, by the way. When you draw the molecular structure, Lewis structure, you're always going to put electrons back in pairs, either bonded or lone pairs, but you're always going to put them back in groups of 2. All right, so if you notice, there's an empty space here for that electron to fit in, and there's another empty space right here. So the easiest way is to just kind of build the structure and put oxygen in the middle because it has the lone areas. Let's just draw it on just like I have here, and put the bromine here, and put a bromine here, and then go back and fill in your electrons. That's one way to do it. I'm not going to draw the electrons, but you get the idea. Okay? So I'll show you some more complicated ones a little bit later, but that's one of the easiest ways. So what do I do if it's a little bit more complicated? Well, one rule is to just take out all the electrons, 6 for oxygen, 14 for the bromine, because there's 2. So what I'm doing is I'm pooling together all of my valence electrons that I have to work with. So that's going to be a total of, 20 valence electrons that I have to use. I'm going to put oxygen in the middle and bromine on either side. Okay, so what I would do is I'm going to put anything from the carbon family in the middle. If there's nothing from the carbon family, then I'll put the nitrogen family. Nothing from there, then I'll put the oxygen family. If you look at the Lewis structures, carbon has 1 open on either side. Nitrogen has 3 open on either side. Okay, so that's why I'm going to put carbon family in the middle first, because it's got more open spaces than the nitrogen does. And if there's nothing from the nitrogen family, then I'll go to oxygen, because oxygen has 2 empty spaces, and I'll never put a halogen in the middle. Very unlikely, unless there's other halogens in there. Okay? Alright, so I'm going to just go ahead and throw a bond here, and then fill them in. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Check, I used all my electrons. Okay? It's as simple as that. Okay? Now they get a little more complicated. I guess I shouldn't say it's as simple as that, but this one was as simple as that. Just double check that you put all your electrons in here. Make sure all your electrons look nice and neat. If you have to, erase, but erase completely. You get a lot of people that will do this when they erase. They'll erase this and they'll kind of come over here and they'll do this sloppy little half erase, and then they'll come back in and they'll draw their Lewis structure right over that. So they'll do another bromine here, and I'm like, wait, is that an electron, or is that, what are their electrons and what aren't? Don't do that stuff either, okay? Nice and neat. Okay, so now ammonia. Nitrogen in the middle, hydrogens all around. Okay, hydrogens all around. I have 5 valence electrons from the nitrogen. I have 3, so I have a total of 8 valence electrons to use. 2, 4, 6, 8. And there's my Lewis structure. All right. Now, carbon dioxide. Okay, so carbon dioxide, I have 4 valence electrons from the carbon. I have 6 from each of those, from each of the oxygens, which is going to be 12. So that's going to give me a total of 16 valence electrons to use. All right, we have carbon in the middle, oxygen on either side. All right, so I'm going to put 1, 2. Okay, so I have 16, so there's 2, 4 taken away, so I'm down to 12. So 2, 4, 6, 8, 10, 12, 14, well, I'm counting off, I'm getting off track here, but let's go ahead and see how many I have so far. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I've used way too many electrons. Okay, so that can't be the structure for carbon dioxide. Right, so that's not going to work. So I got to get rid of that. All right, so when this happens to you, what you're going to have to do is you're going to have to throw in there a double bond somewhere. So you could go ahead and come back and throw a double bond here on this side and a single bond here, and then draw your Lewis string. Okay, problem with this is that that's not going to work either. All right, so you're like, wait a minute, I don't want to keep doing this trial and error stuff. I want to know definitively what I'm going to do right from the beginning. Okay, so this is where I come in and I kind of do another little tip. So let's get this input. I put these up at the top. Okay, so I always put this at the top. That's how many valence electrons I have to work with. Okay, on the bottom, I calculate how many valence electrons do I need for complete stability. So I need 8 for the carbons and 8 for each of the oxygens. So my answer for the bottom part is always 8 or 2, 8 or 2. The only one that's ever going to get 2 is hydrogen. So my answer on the bottom is always 8. So here I have 16. So 16 plus 8 is going to give me 24. Okay, so this is how many electrons that I need to have for stability. This is how many electrons that I actually have to work with. So what I'm going to do is 24 minus 16. So if I do 24 minus 16, what this is going to tell me is how many electrons I need to share. So 24 minus 16 is going to be 8. Now they share electrons in pairs of 2 in what we call bonds. So therefore, I need to put 4 bonds in my structure. So I'm going to put carbon in the middle, oxygen on either side, and I have to put 4 bonds. 1, 2, 3, 4. Okay, now I have to go back to the 16 because that's how many electrons I have to have in my structure. Not 24, but 16. So I do 2 more here, and 2 more above and below the oxygen. Okay, so 2, 4, 6, 8, 10, 12, 14, 16. Here is my correct Lewis structure without going through trial and error and trying to narrow down the number of electrons. I like this method the best. Okay, this method I find is going to work time and time again for you. There will be a couple places it won't work, and I'm going to show you those in the next video. But for right now, that is your best method. Okay, and again, I'll give you step-by-step rules in class. All right, let's just take a look at ozone. Ozone, there's 3 oxygens. Okay, so 3 oxygens. Each one has 6 electrons, so that's 18 valence electrons for each oxygen. Okay, it needs for stability 8, and there's 3 of them, so that's 24. Okay, so what I'm going to do is I'm going to calculate the number of electrons. So 24 minus 18 is going to give me 6. Divide that by 2, that's going to be 3 bonds. Now, you typically don't need to see all this work because you can do Lewis structures in different ways. But again, this is the best way I found to do this. So I'm going to put an oxygen in the middle, an oxygen on either side. What I'm going to do is bond these together. And there's my 3. Okay, so then I can go back and fill in my electrons. I'm going to make sure everything is stable. And by the way, I didn't do that on some of those other ones because I'm just so used to doing them. But you should go back through and make sure that everything's stable, all the lines look nice and even, and that everything is in dots. Okay, well, dots and lines. I'm going to talk about that in just one second. 2, 4, 6, 8, 10, 12, 14, 16, 18. Check. I used all my electrons. Everything is stable, and everything is bonded together. There's your correct structure. And the key, really what you're looking for in this is that you have 3 lines on the ammonia, and you've got a lone pair of electrons here. You've got 4 bonding electrons, 4 bonding pairs on either side of carbon, 2 on either side. 1 and then 2. That's the importance, is we're looking at how electrons are arranged in our structures. Okay? All right. So that's the basics of Lewis structures. All right. I'll see you guys later.